Carbide burrs are indispensable for precision work in metalworking, woodworking, and fabrication, offering unmatched durability and cutting efficiency thanks to their tungsten carbide composition. But one of the most common frustrations users face is persistent clogging, where the flutes, those spiraled or straight grooves designed to channel away debris, become packed with material remnants, slowing progress, generating excess heat, and leading to premature tool wear. This issue isn't just annoying, it can compromise safety by increasing vibration and the risk of the burr binding or ejecting shards, while also inflating costs through frequent replacements. At its core, clogging happens when chips, the small particles sheared from the workpiece, fail to evacuate properly and instead adhere to the cutting surfaces, often due to a combination of material properties, improper technique, and environmental factors. Soft, ductile materials like aluminum, brass, or even certain hardwoods exacerbate the problem because their chips tend to deform plastically rather than fracture cleanly, creating stringy or gummy buildup that welds back onto the burr under friction-induced heat. In contrast, harder metals like steel produce brittle chips that clear more readily, but even there, suboptimal conditions can lead to packing. Understanding the mechanics of chip formation and flow is key. As the burr rotates at high speeds, typically 10,000 to 35,000 RPM, the teeth engage the material at a specific rake angle, the inclination of the cutting face that determines how easily the chip curls and separates. When this process is disrupted, the chips compact within the flutes, reducing the effective cutting area and turning a sharp tool into a dull, dragging one that overheats and dulls exponentially faster. The primary culprits behind clogging often trace back to technique and setup, starting with excessive pressure, which compresses chips into the flutes instead of allowing the tool's rotational force to propel them outward. Many beginners, eager for quick results, bear down heavily, mimicking the force used with files or grinders. But carbide burrs thrive on lightness. Applying more than 1 to 2 pounds of force overrides the designed rake angle, causing the material to smear across the teeth rather than shear off in discrete pieces. This smearing generates localized temperatures exceeding 400 degrees Fahrenheit, softening the chips and causing them to fuse to the carbide, especially on heat-sensitive alloys where thermal conductivity is low. RPM mismatches compound this. Too low a speed, under 15,000 RPM on metals, fails to generate sufficient centrifugal force for chip ejection, while excessively high speeds on soft materials can melt them into a paste. Material-specific challenges play in too. Aluminum's high ductility leads to long, curly chips that tangle if the flute geometry isn't optimized, whereas wood fibers can swell and bind in humid environments. Dry operation without lubrication is another silent killer. Friction between the burr and workpiece builds up static heat, promoting adhesion without any medium to flush debris. Even high-quality double-cut burrs, with their crisscross flutes for better chip breaking, aren't immune if these basics are ignored, as the intersecting patterns create microtraps for compacted material. Over time, this buildup alters the burr's geometry, flattening rake angles and reducing cutting efficiency by up to 80%, forcing users into a cycle of harder presses and more clogging. Lubrication emerges as the unsung hero in preventing clogging, yet it's the aspect most overlooked in tutorials and product manuals, with many assuming carbide's hardness makes it self-sufficient. Cutting oils or coolants, ranging from general-purpose WD-40 for light metals to specialized synthetic formulas for heavy-duty steel, act as both a thermal dissipator and a chip evacuator, reducing friction coefficients by 40 to 60% and preventing the welding of softened material to the rake faces. Without it, especially on non-ferrous metals, chips reattach almost immediately due to the lack of a separating barrier. But a simple application creates a slippery interface that allows chips to slide off cleanly, maintaining the integrity of the flute paths. The rake angle, engineered at 5 to 15 degrees for optimal shear, relies on this low-friction environment to curl chips away without drag, ensuring they break at the tool-chip interface and exit via the rotation's throw. In practice, Users report that lubricated burrs sustain consistent performance for hours versus minutes in dry runs, with less vibration and cooler operation that extends tool life by 3 to 5 times. For wood, a light wax or compressed air blast serves similarly, preventing fiber packing without saturating the grain. Enter the 3-second fix nobody talks about. A preemptive spritz of cutting oil directly onto the burr and workpiece before each engagement, combined with consciously light pressure, it's that straightforward yet transformative, often overlooked in favor of buying specialized anti-clog burrs that cost 20 to 50% more. This ritual takes mere seconds. Pause, apply a quick mist from a squeeze bottle or drip feed, aim for a thin film, not a flood, and feather the tool with the weight of your fingertip, letting the RPMs, dialed to material-appropriate levels, like 20,000 to 25,000 for aluminum, handle the removal. The oil instantly coats the rake faces, lowering adhesion and enabling chips to flow laminarly along the flutes, while light pressure preserves the angle's effectiveness. Avoiding compaction. In real-world tests, this duo clears 90% of buildup issues on the first pass, restoring smooth winding operation instead of the telltale grinding drag. For gummy metals, opt for oils with anti-weld additives. On steels, a water-based coolant suffices to avoid flammability risks. This fix isn't just reactive. Making it habitual prevents the cycle entirely, saving you from downtime scrubbing flutes with wire brushes or solvents, which only dulls edges further. Why does this simple intervention change everything? It addresses the root physics. Clogging is a heat-friction adhesion triangle, and light pressure plus oil breaks it by minimizing input energy and maximizing evacuation. Heavy, dry cuts create a positive feedback loop where partial clogs lead to more heat, more adhesion, and eventual total blockage. But the 3-second routine keeps the system in equilibrium, with chips forming brittly, separating cleanly, and ejecting radially. Professionals in aerospace fabrication or automotive repair swear by it for maintaining precision on high-value parts, where a clogged burr could ruin tolerances or safety margins. Even for hobbyists engraving signs or deburring tools, it means fewer ruined pieces and longer-lasting investments. Your $20 burr suddenly performs like a $50 premium one. Ultimately, if your carbide burrs keep clogging, it's rarely the tool's fault. It's usually a matter of overriding its design through pressure and neglect of lubrication. Embrace the 3-second fix, light touch plus a spritz, and watch as chip flow normalizes, rake angles stay effective, and your workflow becomes effortless. This isn't gimmick advice, it's grounded in material science, turning aggravation into reliability and ensuring your burrs cut as intended, project after project.